In section 11.1, we're going to be learning about one of the conic sections, which is the ellipse. And you already know a little bit about an ellipse from the activity that you did in class yesterday, but let's think about the definition of an ellipse. An ellipse is going to be the set of all points x such that the sum of the distances from x to p and the distance from x to q is k. So what we're talking about is, let's say we choose a point here on this ellipse and we connect P to X and Q to X. As I move that, if I add that, if I call that distance P1 and distance P2, if I call those two distances, that distance is going to be the same. P1 plus P2 is going to be equal to, if I choose another point and I'll make this. So that's what the definition of an ellipse is. Okay, now from that we also have a couple of things that we need to know about. First of all, you have two vertices. Here I have circled in blue. Those would be the vertices. Here we have a major axis on the x. X is the major axis, and we know x is the major axis because it contains our vertices, it's the longer axis, and it also contains our foci, which are points P and Q. The center, of course, is going to be here at the origin this time. And then we have also the minor axis, which is here. And let's look at a quick animation of an ellipse so that you understand here. Here's an example. You can see that the red and the blue are changing as it comes up with different values along the path of the ellipse. But as those values change, you notice that the total length there stays at 10 the whole time. So there we have the definition of an ellipse. Okay, we're going to work through a few examples. Here what we're going to do is show that the graph of the equation 9x squared plus 25y squared is equal to 225 is an ellipse. And we're going to label the foci, the vertices, the major axis, and the minor axis. Okay, so let's work through this problem. We're starting out with 9x squared plus 25y squared is equal to 225. And now we're going to think about what we need to do to that equation to show that what we have is an ellipse. And if you remember, an ellipse is going to be in the form of x squared plus y squared, maybe some denominators, but when those the x squared and the y squared is on the same side, we have it equal to 1. So we're going to divide both sides by the 225 and see what happens. Okay, when we divide both sides by the 225, we end up with x squared over 25 plus y squared over 9 is equal to 1. Now, in this case, it's fine to go ahead and say that what we have is an ellipse. And it's because we have the sum, it's equal to 1, and also we have differing values. 25 and 9 are different values. If those two values were the same, then what we would have is a special case of an ellipse, which would be a circle. So we do have an ellipse here. And now we're going to go through and label the foci, the vertices, the major axis, and the minor axis. All right, so first of all, the major axis is going to be our x. And we might want to rewrite this equation one more time so that we have, this is 5 squared plus y squared over 3 squared is equal to 1. Okay, so we have a major axis on x because the 5 is larger than 3. So x is our major axis, y is going to be our minor axis, and now we need to use the information that we have to find the foci. Okay, so our major axis is going to go 5 each way. All right, so we start with the center at 0. Here's our center at 0. If I move over to 5, that's going to be one vertex and -5, that's the second vertex. And on the minor axis, I use this 3 here. And so I'm going to move up 3 and down 3. Okay? And so my ellipse is going to look something like this. Okay, there's my ellipse. And now I need to label my foci. So to find the foci we found yesterday, and what's going to happen is within this ellipse there's a triangle. And that triangle is going to be, the ellipse is going to look something like this, okay? So along here is our major axis. And our focal point is going to be right here. So I'm going to label that F. That's our focus. Now, although it doesn't look like it in this diagram that I have, this hypotenuse of this right triangle that you have right here is going to be the actual distance from your center to your vertex on your major axis. So in that case, we know that that's 5. And then the vertical distance that we have here is going to be the distance from the center to your vertex on your y-axis, which in this case is 3. So we realize now we have a 3, 4, 5 triangle, or if you don't realize that, then just use the Pythagorean theorem. So the focus is going to be 4 to the right of the origin, or the center, and then 4 to the left of that. So then we have the foci are going to be at plus or minus 4, 0. And so we can label those on here and here. Okay, and so now we have everything we need for that example, and let's go ahead and look at the second example. All right, in this example, we're going to graph the ellipse with the equation 25x squared plus 4y squared using the calculator. So before we graph that using the calculator, we need to come up with a form that is friendly for the calculator, or we need to solve for y, basically, is what we need to do. So I'm going to take that equation and I am going to solve for y. So I'm going to start by subtracting the 25x squared from both sides. That was going to leave me with 4y squared equals negative 25x squared plus 100. And then divide both sides by 4, or every term by 4. And when I do that, I'm left with y squared is equal to negative 25x squared over 4 plus 25. And now I want to solve for y and not y squared, so I take the square root of both sides. And when I do that, I have plus or minus the square root, negative 25x squared over 4 plus 25. Okay, so when you do this, what you have to do in your calculator is you have to let y1 be the positive version and let y2 be the negative version of this. And you have to enter both of those equations into your calculator, or otherwise you will only get half of the graph, half of the parabola. So let's think about what we know here before we get started. It looks like if I were to have just gotten this in standard form, 25x squared plus 4y squared equals 100, then I would have divided everything by 100, and I would have gotten x squared over 4 plus y squared over 25 equals 1. So it looks here, since the 25 is larger than the 4, that the major axis is going to be the y-axis. So let's look and see if that's the case when we graph it. Okay. So if you go to your y equals, you notice I have two equations in. The negative 25 over 4x squared plus 25 raised to the 0.5 or 1/2 there, and then the negative version of that in the y2. I'm going to turn this off for a second. Let's say I only graph the first equation and not the second one. Then what you're going to see is half of the graph here. And we need the other half of the graph, which is why we need to use the negative version. Okay, turn that on, graph. You'll see the second half of the graph. It does have a small break there, but that's about the best job that the calculator will do. Okay. Okay, our next example, we're going to find the equation of ellipse that has the vertices at positive and negative 8, 0, foci at positive negative 3 root 5, 0, and then we're going to sketch a graph using the intercepts. Okay, so what we know about our ellipse is that it's going to have an equation of this form where we need to be squaring something, okay? Now, if the foci are going to lie on the x-axis, that means that our x is going to be our major axis. And you notice that here, that's the case. And then, so you've got vertices at positive and negative 8. So that means because of this, then I'm going to get an 8 here. All right? And then we've got the foci at positive negative 3 root 5. That's not going to be part of our equation. But so what we have is center at the 0, 0. And let's say I come up with this. Okay, remember you can sketch that triangle in here. So let's say this blue point here is going to be our focus. And we know that focus is 3 root 5 from, the distance is 3 root 5 from our center. We don't know what this vertical distance is here, so I'm going to call that B. And then I have that hypotenuse is going to be the same as the distance from the center to, so this is 8 here. So that makes the hypotenuse 8. Okay, so now I have a right triangle, and I'm trying to find B so that I can finish up my equation here. So I've got B squared plus the 3 root 5 squared is going to give me 8 squared. So B squared is going to be 64 minus, if I square the 3, I get 9. If I square the root 5, I get 5. So 9 times 5 is going to give me 45. Okay, and so B squared is going to be it's going to be 19, and then B is going to be the square root of 19. Okay, and so now I can use that to finish out my equation. If B is not square root of 19, then this is going to be square root of 19 here. And then I can leave my equation in this form, or I can change it to x squared over 64 plus y squared over 19 is equal to 1. And we also have here a sketch, and you can label these as negative 8, 0, 8, 0. And then our vertices on our y-axis are going to be root 0, root 19, and this one is going to be 0, negative root 19. All right, and our next example is our last example for section 11.1. You've got a furniture maker, and he has a rectangular block of wood that measures 37.5 inches by 25 inches. And she wants to cut it to make the largest elliptical table possible. We want to find the equation of the ellipse that she can use, placing the center at the origin and the major axis on the x-axis. We want to locate the foci and sketch the graph. So what we're trying to do is really maximize this. So if we think about this on a graph, to start out, it might help us. And let's put that in the center. And what we have is that this is 25 inches, and this is 37.5 inches. Now, from there, if we can talk about and think about a triangle that we can have. So if we make our triangle here, then if we think about this vertical distance, vertical distance being the 25 inches, and we cut that in half, we get 12.5. So this right here can be 12.5 inches. And then we have our hypotenuse is going to be half of our 37.5, which is going to be 18.75. And so then this is going to be the focus, because we're going to come up with an ellipse, because what we're looking to come up with is you know, sort of the maximum area that we can come up with there. So or we're going to use the most of this rectangular block of wood. So we have that as 18.75, and then we're trying to find this distance down here. We'll call this A. Then we're just using the Pythagorean theorem here. So I could say that 18.75 squared minus the 12.5 squared is going to give me the A squared. And so when you simplify that, then you end up with let's see what we end up with. Use a calculator real quick to work on that. Yeah, 18.75 squared minus the 12.5 squared, and that's 195.3125. So then A squared is equal to 195.3125. What you might want to do there is change that to a fraction, and you get 3,125 over 16. And then you take the square root of both sides. And that's going to be equal to, we know the square root of 16 is 4. And then let's do the square root of, and we get about 55. So we might just want to leave that as the square root of 3125 to keep it a little nicer. So the key is that this A squared is this, or A is plus or minus square root of 3125 over 4. When you write your equation, which is what we're trying to do, is write the equation here, you can go back to that nice form for that equation, because so you've got x squared over something squared plus y squared, and you know your y squared is going to be over 12.5 squared equals 1. So this value is something squared right here. What we're going to square is this guy. So this, if you square it, it's basically a squared. So it's your 3,125 over 16, meaning that we can just get rid of this here and say x squared over 3,125 over 16. And now the next thing we were supposed to do is to locate the foci here. Actually, I made a mistake. I'm sorry. This is going to be our foci here. This is not here, because this is our x. This is going to be this distance here. That's my mistake. So that should be 18.75 squared over the 12.5 squared. Now we'll use what I was just talking about to actually find the foci. And again on the x-axis, so we can use the plus or minus square root 3,125 over 16 here, 0. And there we have it. And that's the last problem I'm going to do. In this section, you'll notice you have one more problem, example 5, and we'll work on this one in class together.